All right, so now we're going to look at applications. One of the applications is instantaneous velocity. Velocity is speed, and speed is, you know this, you've seen this in the car, miles per hour. Oh, whoa, hold on, oompa. Let's go back. Speed is like miles per hour. It's a distance over a time. And so generally when we do it, like distance is literally a change in position. And the time has got to be like a starting time and a final ending time and finding the difference. So oftentimes when you're finding out like how fast your average speed or average velocity was on a long drive, like let's say you're going to Disneyland, you're driving at different speeds along the way. You'll hit rush hour traffic, you go slower, but you can find out how long it took your average speed or velocity by finding how much what the mileage is and dividing by how long it took you to drive it. So that is like literally setting it up like this, where S of t is your position function. It gives you, so it allows you to track distance. Instantaneous velocity is like when they detect the speed of a pitch at a baseball game, the cop hitting you with his radar gun. It's instantaneous. So this is like doing the limit as t approaches a. So this is very much along the lines of what we've been doing. In fact, V instantaneous, as we'll see in the next section, ends up being S prime of t when we look at it without A later on. And the reason why the one without A later, the other one's better with the H is like, you'll just like it better. I'll show you. You'll see it in 3.2. So let's say we're doing a rock is dropped from a height of 64 feet. The height function is negative 16t squared plus 64. And we're going to get, it's going from 0 to t to 2 seconds. Metric system is going to have a different equation. Gravity is like 9.81, so it's going to have a negative 9.81 t squared plus some other stuff. So we find the instantaneous velocity at t equals 1. Like when it's on the way to the ground, how fast is it going? We can go through and just apply the limits we've been doing for the last few weeks, figure it out, and we get down to negative 32, which is, since this was in, it said feet, 64 feet, and this was in seconds, we get negative 32 feet per second. It's negative because we're going downward. So normally we say like upwards is positive and downwards is negative. We're treating the velocity is going downward as negative. Then I've got an economics problem. Let's say a gaming company sells X electronic gaming systems at a price P of X equals negative 0.01X plus $400 per gaming system. And so that's like the price or cost of produce, or the cost of producing the games. Well, price, no, I'm sorry. That's the price they sell it at. Revenue, I got it right here. Revenue is price times quantity sold. Quantity sold, we're going to call X. Price allows us to use, because that we said per system, and so X is the system here. Price will be this P of X function. So I've got it written right here. It's going to be P times X. The cost of producing the games, there's different costs. It costs $100 to make each game, and then there's an extra $10,000 no matter how many games they produce. These, when there's a fixed cost, regardless, there's a price that isn't dependent on how many you produce. It's called a fixed cost or overhead. It counts as things like rent on the warehouse and stuff like that. And like stuff, even if you didn't make anything, you're still paying for the rent on the warehouse, stuff like that. The profit from selling these is revenue minus cost. So we will do R of X minus C of X to get like a big P of X. Here, this was a little P of X up above. So if we write out what this was my P of X times X, that's the R of X. If I distribute the X and I combine it, I get my profit function to look like this. And so what we're going to check is the rate of change of profit. What is the rate of change of profit if they make 10,000 games? So we're going to do the function this is doing, limit. We're doing f of x minus f of a over x minus a, limit as x approaches a. F of x is our P of x. A is our 10,000, because that's the number of games we're looking at. So going through this is kind of tedious because there's some big numbers here. But you plug it in, like that's the P of x, that's the P of 10,000. I figured out what it was. This is easier when you get to this step after you've added them together if you factor out negative 0.00 or negative 0.01. It will change the sign of everything and it adds 2 zeros. But at that point, factoring is easy because you don't have any weird coefficient in front of x. It especially helps knowing that you need the x minus 10,000. That's what I did over here. I'm like, I know x minus 10,000 is one of them. What does the other factor need to be? The other factor needed to be 20,000 because I just divided. I literally did that to figure out what was going in here. Once those cancel, we have a nice little value. We figure out that it's 100 and it's positive. So it's positive, and this is the rate of change of profit. That means at 10,000 games, it's profitable to make more games because their profit value is still going up. If this is their profit function, their profit is still going up. And so they should produce more games. They should produce more games to get what they want. Profit will go up if they produce more. So we're almost done with limits. Just a quick recap. What we did in this section was this. We did that, the two different f prime of a's. Where we're headed is kind of like this. But we generally don't say x naught, we just say x. And so we don't use x naught, we use x. And that makes this the better one to use because then there's no confusion with the first one. We will, after we go through some limits, we'll see like if f of x, that's not what I wanted. If f of x equals x to the n, we'll see f prime of x is this. We're going to work this kind of stuff out with limits. We see if we start with trig functions, we'll be able to figure out what the derivative is with trig functions. That's what we're doing next. Okay? Peace.